Every time you swipe your credit card, every time you book a flight, and every time your paycheck hits your bank account, you are triggering a ghost. You are sending a signal to a machine that was likely built before you were born, running code that was written when the Beatles were still together. We like to think the modern world is run on Python, Java, and the cloud. We obsess over AI and the newest iPhone. But the actual money, the $3 trillion that moves through the U.S. financial system every single day, isn't run by the cloud. It's run by this. This is the iron skeleton of the global economy. The language is called Cobol, Common Business-Oriented Language. It was created in 1959. By all logic, it should be dead. It's verbose, clunky, and ancient. And yet, right now, there are over 220 billion lines of COBOL code in production. And that number isn't going down. It's actually going up by 1.5 billion lines a year. But there is a problem, a terrifying problem. The people who know how to maintain this code are dying. They are retiring. They are in their 70s and 80s. The banking industry is sitting on a ticking time bomb. The software that holds the world economy together is being run by a generation that is leaving the workforce, and nobody is replacing them. This is the story of the code that refuses to die. The story of the Greybeard programmers who are the only ones keeping the lights on, and the desperate trillion-dollar gamble to replace the unreplaceable. This is the story of Cobol. To understand why we are still stuck with this ancient technology, we have to go back to a time when computers were the size of rooms and had less processing power than a musical greeting card. The year is 1959. The computing world is a mess. Every manufacturer, IBM, Honeywell, Univac, had their own proprietary language. If you wrote code for an IBM machine, it was useless on a Honeywell machine. It was a Tower of Babel. Enter Grace Hopper. Amazing Grace. A rear admiral in the U.S. Navy and a mathematical genius. She had a radical idea. She believed that code shouldn't look like algebra. It shouldn't be a mess of hieroglyphics that only mathematicians could read. She believed code should look like English. Look at this. This is Cobol. It doesn't look like code, it looks like a sentence. Multiply hourly rate by hours worked, giving gross pay. This was revolutionary. It meant that business managers, people who weren't scientists, could look at a printout and actually understand what the computer was doing. The Department of Defense loved it. They were tired of buying different computers that couldn't talk to each other. So they effectively put a gun to the industry's head. They said, if you want to sell computers to the U.S. government, they must run Cobol. Overnight, Cobol became the standard. Banks, insurance companies, and airlines flocked to it. They spent the 1960s and 70s writing millions of lines of code to digitize the global economy. They built the foundation of the modern world, and they built it to last. You might be asking, okay, that was 60 years ago. Why haven't we upgraded? Why don't banks just rewrite their systems in Python or Java? It's a logical question, but it misunderstands what banking is. Banking isn't about speed. It isn't about moving fast and breaking things. If Facebook crashes for an hour, people get annoyed. If the ledger of Chase Bank crashes for an hour, the economy collapses. Banking is about accuracy. And this brings us to the secret weapon of Cobol, the reason it is immortal. Let me show you a math problem. If you ask a modern computer language like Python or C++ to add 0.1 and 0.2, what do you get? You get 0.300000000300004. Why? Because modern computers use something called floating point arithmetic. They prioritize speed over precision. They estimate numbers in binary. For a video game, that tiny error doesn't matter. But for a bank, If you are processing a billion transactions a day, those tiny fractions of a cent add up to millions of dollars lost or created out of thin air. You cannot have floating point errors in finance. Cobol uses fixed point decimal arithmetic. It calculates numbers exactly the way a human does, digit by digit. It never rounds off unless you tell it to. It is mathematically perfect for money. Then there is the reliability. These mainframe systems are designed to run for decades without a reboot. There are COBOL programs running today that were compiled in 1980 and haven't been touched since. They just work. In a world of constant software updates and patches, COBOL is a rock. And banks love rocks. But there was one moment when this legacy code almost destroyed civilization. The year 2000, Y2K. In the 60s and 70s, memory was expensive. 1 megabyte of storage cost millions of dollars. So, COBOL programmers saved space by shortening dates. Instead of 1975, they just wrote 75. They assumed their code would be replaced long before the year 2000. They were wrong. As the millennium approached, the world realized that when the clock struck midnight on December 31st, 1999, the computers would think it was the year 1900. Interest rates would invert, mortgages would disappear, power grids would shut down. This sparked the greatest mobilization of the workforce in history. Corporations dragged retired COBOL programmers out of Florida retirement homes. They offered them $500, $800, $1,000 an hour to come back and fix the code they wrote 20 years earlier. The U.S. alone spent over $100 billion fixing Y2K. It was a massive success. The world didn't end. But it had a side effect. It taught the banks a dangerous lesson. They thought, okay, we fixed it. Now we can ignore it for another 50 years. They stopped training new people, universities stopped teaching COBOL, and the workforce began to age. Fast forward to April 2020, the pandemic hits. Millions of Americans lose their jobs overnight. They all log on to their state websites to file for unemployment, and the systems crash. New Jersey Governor Phil Murphy went on TV and said, "We have systems that are 40-plus years. There will be lots of postmortems, but literally, we have systems that are written in COBOL. We need volunteers, anyone who knows how to program this legacy language." It was a desperate public plea. The governor of New Jersey was literally begging for COBOL programmers on live TV. Why? Because the unemployment systems were running on mainframes from the 80s. When the traffic spiked 1,000%, the code held up, but the changes needed to process the new federal relief checks couldn't be written fast enough. This exposed the Greybeard crisis. The average age of a COBOL programmer is 58. Many are in their 70s and 80s. I spoke to one of these programmers. He goes by Bill. He lives in Texas. He retired 10 years ago, but every few months a bank calls him. They have a bug in a subroutine that calculates international interest. Nobody currently at the bank knows how it works. It's black box code. Bill charges them a consulting fee that would make a lawyer blush. He fixes the line of code and he goes back to fishing. This is the reality of the financial system. It is being maintained by a shadow workforce of retirees, and every year there are fewer of them. So why don't they just rewrite it? Why don't they just migrate to the cloud? Because migrating a mainframe is like trying to change the engines of a Boeing 747 while it is flying full of passengers over the ocean. In 2018, TSB Bank in the UK tried to migrate their systems. It was a disaster. Customers were locked out of their accounts for weeks. People could see other people's bank balances. The CEO was forced to resign. The cost? Over $400 million. The risk of failure is too high. A CIO looks at a migration project and sees a career-ending risk. If they do nothing, the system runs. If they try to modernize and fail, they are fired. So they kick the can down the road. It can be done. The Commonwealth Bank of Australia successfully replaced their core banking system with SAP. It took 5 years and cost over $1 billion. But they're the exception, not the rule. Most banks are choosing a middle path, wrapping. They take the old, ugly Cobol code and they wrap it in a modern layer of Java or Python. When you use your beautiful, sleek banking app on your iPhone, that app is just a pretty face. It sends a request to the Java layer, which translates it into Cobol, which talks to the mainframe from 1970. It's layers upon layers of digital duct tape. So, how does this end? IBM, the guardian of this legacy, has a new plan: artificial intelligence. They're training AI models to read COBOL code and translate it into Java, or to read the COBOL and explain to a human what it does, so a young programmer can understand it. It is a race against time. Can the AI learn the language before the last human who speaks it passes away? We live in a world obsessed with the new, but the next time you tap your card to buy a coffee, take a second to appreciate the old. Deep beneath the surface of our high-tech world, there is a 50-year-old engine chugging away. It isn't pretty, it isn't cool, but it is the only thing stopping the global economy from grinding to a halt. Cobol isn't going anywhere. It will likely outlive me, and it will likely outlive you. It is the invisible, immortal code.